Hello and welcome back to another episode of what's going on here? Why'd they get so bright? Oh, that reminds me of a possible joke later. Okay, so as you saw in the lesson, we have special names for these triangles. This is the opposite side. This is the adjacent side. And of course, the hypotenuse is over as the hypotenuse. But when we start getting ratios set up, like the op over the hype, the opposite of A over the hypotenuse, we call this the sine ratio. It has a special name because these ratios are the same for every triangle. Let's say this is 50 degrees. Every right triangle in the world with a 50 degrees in it is going to have the same ratio, the sine of 50, in fact. And it would be written like this, sine 50. And we can go look it up. We can look it up in our calculator. I'll try to go over this more later, but it's on my mind. There, the ratio is about 0.766. And these numbers go on forever like pi. In fact, remember pi is a ratio of a diameter to the circumference. Sine is a ratio of this side to this side. And yeah, for almost all degrees, it's a crazy number that goes on. That's related to the square root of 2 and just like weird and stuff. There's a couple of angles where it like perfectly lines up, like 45-degree angle, I believe, is one of them. All right. Anyway, there's more ratios to keep track of, right? There's the adjacent side, my boy, adjacent. I love that side, and that's called the cosine. And we have a cosine of 50. Again, is the ratio of this length to this. We could measure them if that's really 50 degrees. Wouldn't it be so cool if it was? It is not. It is 36 degrees. Shoot. You don't have to fix this, obviously, if you're taking notes. And then there is the last one, which is the op and the adjacent. Forget the hypotenuse. Let's just get the ratio of the opposite to the adjacent. And that one we call the tangent. I put those parentheses in the wrong place. Hilarious, man. It's almost 9 o'clock at night. I can't catch a break. 60, whatever. Well, no, it's not whatever. 36. How can you? Well, first of all, you might be thinking, what if we put the hypotenuse on the top? Well, yes, there are 3 more ratios, but we don't have to learn them because you can do everything with these 3. You can do anything and everything with these 3. This is enough. In fact, you could probably get away with just cosine and tangent, or just sine and tangent, or just sine and cosine, because between sine and cosine, all 3 sides are involved: the opposite side, the hypotenuse side, the adjacent side, and the hypotenuse side again. But you could find with just a degree and one side. Let's say the side is 12 inches long. Now we can figure out all the sides because we have the 90, we have the 50, and we have one measurement. We could use the sine to do some algebra and figure out what this side is. And we're going to learn that algebra sooner or later. Don't worry. And then we would use the cosine to figure out this ratio, and we'd be done. So we only need these 3. We don't need to learn the other 3. You can learn them later, like pre-calculus. For now, we're just doing sine, cosine, and tangent. The sine ratio, the cosine ratio, and the tangent ratio. So, let's do some problems. So, using A as a reference, the sine of A is going to be, without any numbers, this is the op of A, the opposite, and this is always the hypotenuse. So CB, whatever that, remember 2 letters in geometry equals the length of CB over the length of AC. And it wouldn't matter, it'd be the same as if we wrote BCCA. Doesn't matter what order the letters come in. On the assignment you're about to do, I tried to pick the most logical order for the multiple choicing. Let's do cosine A. Cosine, my fave, involves the adjacent. Adjacent is AB here. Sorry, cosine A involves the adjacent. And so some people like to write this. The cosine is the adjacent over the hypotenuse. The adjacent in this case is AB. The hypotenuse is AC. Done. And the tangent of A is the op over the adjacent, which the op is CB or BC, and the adjacent is AB. Okay. Now you might be about this time thinking, is there some sort of memory helper or mnemonic device? Yes, it's famous. Everyone who's been through high school knows this. It's called SOHCAHTOA. Because so SOHCAHTOA gets stuck in your head. It's a funny phrase. Sounds weird, and I hate mnemonic devices. I just like to remember things without mnemonic devices. But I'll tell you the truth, I needed this mnemonic device to pass my tests in high school and college. Everyone uses it. The sine is the opposite over the hypotenuse. So that's the SOH. So everyone writes this at the top of their test. SOH, CAH, TOA, SOHCAHTOA. Remember, it's ka. So maybe it should be SOHCAHTOA, but no one says that. They say SOHCAHTOA. Because this is the adjacent, right? Over the hype. The cosine is the adjacent over the hype. The tangent is the opposite over the adjacent. And the sine is the opposite over the hypotenuse. So get ready to write this like 4 or 5 times this year and use it 50 to 70 times because you will be using it. Let's do another problem. Because on the assignment you're about to do, there's some... Let's use this angle. Let's call it J. JD. JDA. I don't know why I went with A again. We're going to use J as the reference angle. And I'm going to do some... let's do 3, 4, 5. That is a valid right triangle. The sine of J. Well, sine. Oop. I need to remember. I will use SOHCAHTOA. The sine is the opposite over the hypotenuse. Opposite of J is 4. Hypotenuse is always 5. Now this is kind of nice because the next one has the hypotenuse in the denominator also. The cosine of J is the adjacent over the hypotenuse. I already know the hypotenuse. I just wrote it. It's 5. It's always 5. But what's the adjacent? What's adjacent to J? 3. And now I can just use these numbers because I want opposite over adjacent, which is going to be 4 over 3, for the tan. But let's say you wanted to go back to the thing, tan. Opposite for adjacent is 3. 4 over 3. And because the hypotenuse is the longest side always of a triangle, these first two are always going to be less than 1, if you think about it. Because their denominator is always the biggest side. But the tangent's the wild card. Tangent could be anything. Because these two sides can be, one could be super big, one could be super small. I mean, imagine this triangle. Just imagine this. And let's do, let's call this corner T. No, that was a terrible letter. Why did I pick that? Okay, whatever. So what's tan T? Well, tan is TOA. Opposite over adjacent. Let's say this is 10 and this is 2. Well, now the tan T is going to be 5 because opposite over adjacent. So tan can be big, but sine and cosine are always small. Like this is 0.8. It's less than 1. This is 0.6. So I think that should get you ready for the second assignment.